Welcome to the Deep Dive. Today we're venturing into, well, a truly immense landscape,
Good.
deep time, like billions of years, stretching so far beyond our everyday experience, it's almost impossible to really grasp.
Yeah, it really is.
We've gathered some fascinating material, and our goal is, to pull out the key ideas, give you a real feel for this profound concept, and maybe even some surprising new ways to think about time itself.
It's remarkable, isn't it, how many different fields deep time touches? I mean, it's fundamental not just to geology, obviously,
Right.
but also to understanding biology, how we approach philosophy, and even, how we think about our responsibilities to the environment. It really compels us to consider timescales that make human history look like, well, the blink of an eye.
And that's the challenge, isn't it? Our minds, they sort of develop to navigate the immediate, the short term.
Exactly. Survival, basically.
So trying to truly comprehend eons and epochs, that's a real hurdle. We're going to explore where this revolutionary idea of deep time actually came from and why it's still so relevant for you today.
Okay. Let's maybe start by considering how people thought about time before this concept really took root.
Yeah.
It's easy to forget that for the longest time, views on Earth's age were based on much, much shorter timelines, often connected to religious interpretations.
Exactly. If you think back before the 18th century, you had figures like Archbishop James Ussher in the 17th century.
Oh yeah, the famous calculation.
Right. Famously calculating creation to have occurred in 4004 BCE.
Yeah.
I mean, that's an Earth that's less than 6,000 years old.
It's astonishing now, but that time frame was, well, pretty widely accepted.
Yeah.
Precisely. That 6,000-year estimate held significant sway. But even then, some thinkers were beginning to question those boundaries.
Like who?
Well, in the early 1700s, you had Benoit de Maillet suggesting Earth might be as ancient as 2 billion years.
Whoa, okay. That's a big jump.
Huge jump. And later that century, Comte de Buffon, using physics, suggested around 75,000 years. Still way off, but...
Still a definite shift away from just 6,000.
Definitely. These were significant departures, even though, they still drastically underestimated the planet's true age.
But it was really James Hutton, wasn't it? The Scottish geologist, late 18th century. He fundamentally changed our understanding.
Absolutely. Hutton was the key figure here.
Just by looking at the landscape in Scotland.
Pretty much. His meticulous observations were pivotal. He saw processes like, sediments layering up, erosion by wind and water, rock strata being lifted, happening at such an incredibly gradual pace that the Earth had to be vastly, vastly older than anyone had previously conceived.
That famous line, no vestige of a beginning.
No prospect of an end. Yeah, from 1788. That truly captured the idea of an immeasurably deep history.
And his principle of uniformitarianism, sometimes called actualism, that was central to this breakthrough, wasn't it?
It was crucial.
The idea that the same slow geological processes we see today, like mountains wearing down, sand being deposited, they've been shaping Earth forever.
That's right. And what's interesting here is that this was a real paradigm shift, a huge one.
How so?
Well, it moves away from explanations that relied on sudden, catastrophic events or supernatural forces.
Right, like floods or divine intervention.
Exactly. It provided a testable, physical basis for understanding Earth's immense age. Hutton basically grounded Earth's history in observable natural processes that are still going on.
Okay. And then following Hutton, a whole group of other thinkers kind of built on that foundation.
Yeah, it wasn't just him. You had Charles Lyell in the 19th century, his Principles of Geology.
Hugely influential, right? Popularized uniformitarianism.
Massively. And incredibly, it influenced Darwin's thinking. Darwin needed that immense time scale for evolution to even seem possible.
Wow, okay. So Lyell provided the detailed evidence.
He did. Meticulously showed how these slow, continuous forces could account for the planet's vast geological features. But then there's also Georges Cuvier.
He was more into catastrophism, though, like sudden events.
He was, yes, arguing history was punctuated by these violent events. But importantly, he still made enormous contributions to paleontology and understanding extinction as a natural part of Earth's long story.
Okay, so even opposing ideas contributed. And William Smith, faunal succession.
Yeah. William Smith, crucial. The realization that different rock layers contain distinct groups of fossils, and they appear in a specific order.
So you could tell which rocks were older just by the fossils.
Exactly. That was absolutely key to developing a relative geological timescale, knowing what came before what. It forged this fundamental link between biological time and geological time.
Makes sense.
And we shouldn't forget John Playfair. He kind of took Hutton's often quite dense technical ideas
And made them understandable.
Yeah, made them accessible to a wider audience through his writing. So the development of deep time was really a collaborative effort, an intellectual journey.
Okay, so we've established this mind-bogglingly long history for Earth. But how does deep time actually help us understand the slow grind of geological processes? Things we just can't see happening day to day.
Well, connecting this to the bigger picture, deep time provides the absolutely necessary space, the temporal space, for these tiny processes to result in huge transformations. Like the Grand Canyon, carved by the Colorado River, grain by grain, but over millions of years.
Right.
Or the Himalayas, pushed up by tectonic plates moving just, a few centimeters a year?
The tiny movements.
But doing that over tens of millions of years creates the highest mountains on Earth. Without deep time, these features just wouldn't make any sense.
And those unconformities, like the one Hutton saw at Sycar Point. You said those are like visible gaps, huge missing chapters in the Earth's history book.
Exactly. That's a great way to put it. An unconformity represents a break, a gap in the continuous laying down of rock layers.
So you can literally see different time periods right next to each other.
You can. It's a place where you might see, say, ancient tilted rock layers that were eroded down, and then much younger horizontal layers deposited right on top.
Wow.
So for you, the listener, imagine opening a history book and finding entire chapters ripped out and replaced with pages from a totally different story, all bound together. Sycar Point was this powerful visual proof for the immense time involved.
But the real breakthrough, the thing that gave us actual numbers, had to be radiometric dating in the mid-20th century.
Oh, absolutely. That was the game changer.
Suddenly, we could assign numerical ages to rocks and fossils.
Precisely. Radiometric dating uses radioactive isotopes, unstable atoms that decay at a predictable rate, like a natural clock ticking inside the rocks.
A clock, okay.
Yeah. It allowed us to move beyond just knowing the relative order of events like Smith did with fossils to determining roughly when they occurred in years.
And that confirmed Earth's age.
Confirmed it. Around 4.54 billion years old. It provided concrete evidence for the deep time that Hutton and Lyell had argued for based on observation.
What kind of dating methods are we talking about?
Well, techniques like uranium-lead dating for really, really old rocks, and things like carbon-14 dating for younger organic materials. It gave us this powerful new toolkit.
So it wasn't just about getting a number.
No. It was about shattering that human-centric timeline, revealing a history so vast it just redefines our whole existence, really.
And this led to the geological timescale we see now, with the eons, eras, periods, all those names.
Exactly. That whole hierarchical system, eons like the Precambrian and Phanerozoic.
Cambrian being most of Earth's history, right? Like 88%.
Roughly, yeah. A vast period dominated by microbial life before complex creatures really took off.
And then the Phanerozoic, the age of visible life.
Right, which includes the Paleozoic, Mesozoic, the age of dinosaurs.
Everyone knows the Mesozoic.
Yes. And the Cenozoic, the age of mammals, which includes us. These boundaries between the major divisions often mark significant geological shifts or big biological turnover events like mass extinctions.
So it's a framework to help us organize billions of years.
Basically, yes. It helps us make sense of it all.
So deep time isn't just about the rocks themselves. It's absolutely fundamental to understanding the history of life on Earth too, isn't it? Evolution playing out over billions of years. It's almost impossible for us to truly fathom.
It really is. Deep time provided the essential, the canvas for evolution to unfold. The gradual accumulation of genetic changes, the diversification of life from the simplest single cells to, the incredible complexity we see today.
It just needs that time.
It simply requires these immense stretches of time. The acceptance of deep time in geology was absolutely crucial for Darwin's ideas about natural selection acting over vast periods to be accepted later in biology. Without it, evolution would have seemed utterly implausible.
And the fossil record is our main window into this incredibly long journey, showing simpler organisms in older layers.
That's right. The fossil record is the tangible evidence. That principle of fossil succession, different species appearing and disappearing in a specific, predictable order through geological history.
That's Smith's idea again.
Yes. It lets us correlate rock layers even across continents and piece together the picture of how life has changed over billions of years.
And index fossils, what are those?
Index fossils are particularly useful. They're species that were geographically widespread but only existed for a relatively short period of geological time.
So they really pinpoint a specific time.
Exactly. They're like time markers in the rock layers.
And the fossil record also shows these dramatic periods of rapid extinction, the mass extinctions followed by bursts of new life.
Yes, precisely. Deep time allows us to see these long-term trends in biodiversity, the rise and fall of different groups.
Which has relevance today?
Absolutely. Studying past mass extinction events within this huge time frame can give us critical insights into the potential causes and consequences of the biodiversity loss we're seeing now. It makes it incredibly relevant.
It's almost overwhelming just thinking about billions of years of Earth's history.
Yeah.
But then you realize even that is a relatively small chapter in the story of the universe itself, right?
Yeah, now we're talking cosmic deep time.
Taking it up another level.
If we connect this to the even bigger picture, yes. Earth's 4.54 billion years are sort of nestled within the universe's approximately 13.8 billion year history, starting with the Big Bang.
So cosmological timescales dwarf even geological time.
They do. It puts our planet's existence within an even more expansive context.
And stars and galaxies.
Uh-huh.
They have life cycles unfolding over millions, even trillions of years.
That's right. The scale is just astronomical, literally. Stars are born in nebulae, they live fusing elements, then they die. Some fade, some explode as supernovae.
Leaving behind neutron stars, black holes.
Exactly. And galaxies themselves interact, collide, merge, evolve over billions of years. These are processes happening on timescales just way beyond our direct human experience.
And Earth isn't isolated in this, right? Cosmic events can affect us here, things like gamma-ray bursts or orbital cycles.
Precisely. Earth's geological and biological history is deeply interwoven with the cosmos. Think about Milankovitch cycles.
Those long-term wobbles in Earth's orbit and tilt.
Yeah, they drive significant climate changes over tens to hundreds of thousands of years, influencing ice ages, sea levels, and the giant impact early on, the one that likely formed our moon. Probably played a crucial role in stabilizing Earth's axial tilt, which gives us our seasons. It really highlights the interconnectedness of everything across deep time.
This whole concept, it really forces you to reconsider humanity's place in the grand scheme, doesn't it? It's a real challenge to our usual, human-centered view.
It absolutely is. Deep time just reveals how recently we arrived on the cosmic stage. When you consider what some call rock time, this vast history, utterly devoid of a human perspective.
It's humbling.
It profoundly diminishes our perceived significance. We are a very, very recent addition to a story that's been unfolding for billions of years before we even showed up.
And it raises some serious ethical questions, doesn't it? Especially now in the Anthropocene, with our huge impact on the planet.
Yeah.
Thinking in deep time makes you confront the long-term consequences of things like climate change.
Exactly. And this is precisely where what we might call deep time literacy becomes so critically important.
Deep time literacy.
Yeah, understanding these immense timescales and recognizing that the decisions we make today will have repercussions stretching for millennia, far beyond our individual lives or even national histories.
So it demands a longer-term ethical view.
It necessitates it. One that considers the well-being of future generations, the health of the planet itself over these vast stretches of time.
Ultimately, grappling with deep time has a profoundly humbling effect, you were saying.
It does. It encourages us to adopt a less self-centered perspective.
Seeing ourselves as just one part of a much bigger, evolving natural world.
Precisely. It challenges those inherent anthropocentric narratives, the ones that tend to place humans at the pinnacle of everything. By truly starting to understand the vastness of time, we can hopefully move towards a more interconnected and ultimately more responsible relationship with the planet and its future.
No, actually trying to visualize billions of years, that's still incredibly difficult. That's where those analogies come in, like Carl Sagan's cosmic calendar.
Right, these analogies are incredibly useful tools. They give us some sense of the scale, even though they inevitably have limitations.
So Sagan's cosmic calendar compresses the whole 13.8 billion years of the universe into 1 year.
Yeah. And it powerfully shows just how late humanity arrives, like literally in the final seconds of December 31st.
Wow. Or the football field analogy. Earth's history is 100 yards.
Right, and all of human history is just a tiny fraction of an inch right at the very end zone. Or you have the toilet paper timeline. Each sheet is a huge span of time. Human history is maybe a tiny bit of the first sheet.
Right, or the outstretched arm. Human existence is just Filing your fingernail?
Exactly, filing off a tiny sliver at the tip. And there's the 24-hour clock idea, too, compressing geological time into one day.
They're all attempts to bridge that huge gap between our everyday perception of time and these almost unimaginably long durations.
They do offer a more intuitive way to grasp the relative proportions, but it's important for listeners to remember they are simplifications.
How so?
Well, they can sometimes inadvertently downplay the incredibly gradual pace of many ancient geological and biological processes. It wasn't all sudden jumps.
Right, which brings us to maybe the core challenge. The fundamental difference between deep time scale and our own human experience of time. It's like our brains just aren't wired for it.
That's a crucial point. Our historical timeline is thousands of years. Our lifespans are decades. Compare that to billions of years. The disparity is just staggering.
You mentioned perissodactyls, horses and rhinos.
Yeah, that group of mammals has been around for tens of millions of years, a time frame vastly longer than modern humans have existed. Our perception of time is inherently subjective, shaped by attention, memory, emotion.
Evolved for the short term.
Primarily, yes, for immediate survival, social stuff, not for contemplating eons.
So trying to truly feel or internalize deep time is almost impossible, like trying to sense something our senses just aren't built for.
Pretty much, and that's why this idea of consciously cultivating timefulness or deep time literacy is gaining traction. It's seen as increasingly important now.
Making a deliberate effort to engage at these timescales.
Exactly, because it has the potential to foster a longer-term perspective, maybe greater patience, and hopefully a more responsible approach to the complex challenges we face globally.
It's about consciously trying to move beyond that purely human-centric viewpoint and beginning to see ourselves as part of this much grander, much longer story that's still unfolding.
Precisely. That's the heart of it.
Well, this deep dive into deep time has been truly eye-opening. I mean, it's just astonishing to consider the sheer immensity of it all, the universe, Earth's history, and how incredibly recent we are.
What's remarkable is how this understanding, this developing deep time literacy, can genuinely shift your perspective on the present moment right now.
How so?
It provides a much broader context for the challenges we face and for the long-term consequences that our actions today might actually have.
Okay, so as we bring this deep dive to a close, here's maybe a thought for you, our listener, to consider. Knowing this immense vastness of time that stretched before humans even existed, and the potential for eons to continue after us, how does that understanding fundamentally change your perspective on the significance and the impact of our actions right here, right now, in the present day?